Hello class, my name is Dr. Nicholaus, and this is my project. The title of my project is Product Sales Status and Classification Prediction Model. It's for PackMart Store Inventory Department. Problem statement. This project aims towards resolving ongoing problems of inventory losses, high inventory holding costs, and longer average age of inventory. These issues impact the firm's profitability, operational efficiency, and consequently, investors' confidence with the firm. And thus prospective and continuing investors. Project objective. The objective of this $500,000 project is to create a classification learning model to predict the sales status of active inventory products. We expect to use historical inventory data to train, test, and score the model. We're going to use active inventory to make predictions. We're going to fit the active inventory data to the algorithm to extract sales predictions. Once a satisfactory prediction score is achieved, the model will be used to support inventory decision-making in the firm. The other objective is to prepare a business requirement document. Also, we expect this project to have a timeline of 2 months. So these are the functional business requirements. These are the functions of the system required for it to function and produce the desired business goals. The first requirement is that the system will enable users to update and save inventory information daily. The system will allow analysts to query information for predictive analysis. It will also enable analysts to configure select data variables into selected classification algorithm, either it's random forest or either one. And also it will enable inventory managers to assess inventory predictions for inventory decision-making within the firm. Efficient inventory decision-making. Non-functional business requirements. These are requirements that establish critical user expectation and product control qualities of inventory management system. These requirements are discussed, assessed, and reevaluated by all project stakeholders. Each requirement has a qualitative and quantitative base to establish the effectiveness and usability of the system. They also describe the usability, reliability, performance, security, and documentation requirements of the system. For example, one of the reliability requirement of the system is that the model will maintain a prediction score that is greater than or equal to 85%. The system's cycle time will not exceed 1.5 days. This describes the performance requirement of the system. Also, all users must engage with the system using authorized hardware and networks. This describes the security requirement of the system. Analysts must split data into 80% to 20% sample size. So the 80% sample will be used for training and the 20% sample will be used for testing and scoring the model. This research shows that 80 to 20% training to testing samples is the most efficient way of training and testing models in the machine learning world. Use cases and user stories. These are some of the user stories. I just had 2 of them that explain users' working requirements for the system. They define the role of user to the system. Specific users wants from the system and corresponding value derived from the system. So for example, the first example is as a business analyst. So that defines the role of the user to the system. I want to assess and query information. So that's the specific users want from the system, so that I can perform predictive analysis. So that's the corresponding value derived from the system. Another example is as an inventory manager, I want to assess predictive outcomes so that I can inform my ordering decisions. From those user stories, we derive the use case diagram. So the use case diagram displays the relationships between the actors and the classification system. So the actors in this case are the business analyst, the data scientist, and the inventory manager. So one of the use cases that is displayed over there is that the business analyst specifically requires the system to collect data, prepare data, testing data, scoring a model, and applying the model. The sequence diagram. The sequence diagram shows all parts and interactions that make up the machine learning environment. These include the parts of the system which are the inventory clerk, the database, the machine learning model, the business analyst, the inventory manager, and the inventory ordering system. It also communicates interactions and the flow of information between and among actors and objects. These are shown by solid dashed lines, solid and or dashed lines up here. The vertical dashed lines and rectangles for each of the parts represent the lifelines, representing the existence of an actor or object over time. Lastly, the alternative frame down here is used to symbolize a choice between two message sequences. So for example, the first alternative frame shows the message sequence when it is predicted that the inventory will be sold. And the last one shows when it's predicted that the inventory will not be sold anytime soon. So we'll have the second alternative frame at the bottom part over here. Data dictionary. So data dictionary defines the way data is structured for the machine learning project. So here the entities, attributes, corresponding attributes, and kinds of data stored in each attribute and relationships between entities are clearly defined and communicated. For example, the entities, the attributes for the employee entity, which is represented in this table, includes the employees' names, addresses, department, and email address. The first name of the employee can hold character data with the value range of up to 40. One of the relationships displayed in this data dictionary is that each order will be made by an employee, by the employee may have one or more inventory, and each department has one or more employee. The data flow diagram. This illustrates the overall process of applying the already tested and trained model to new daily inventory data to make sales predictions for each inventory. Evaluation or return on investment and expected outcomes. So there are 3 business objectives of the project. These are, first, to lower holding cost from $10 per unit product to $7.5 per unit product over 2 years. We also expect to lower the average age of inventory from 10 days to 4 days over one year period. We also expect to minimize inventory wastage and losses from $1 million per year to under $1 million in 1 year. All these goals satisfy the SMART goals that we discussed earlier in the class. So they're specific, they're measurable, they're acceptable, they're reasonable, and they're time bound. Ethical concern. So the model can learn that customers consume certain unhealthy products and predicting more, thus leading to prediction of more sales and inventory orders to retain the unhealthy habits of behaviors. This problem is that without healthy customers in the long run, the grocery firm might enhance some value to competitors through alteration of brand, public perception, and other industries like healthcare through the manifestation of opportunity costs related to unhealthy behaviors. To strategically absorb the outlined ethical concerns, the model deployment should include free diet consultation services for all customers. Dietitians will guide and educate customers on their grocery shopping behaviors, and this might influence the model's prediction capacity to address the concern at hand. Also, competitively, the strategy will portray a strong value proposition for the customers in the long run, as customers today are becoming more health conscious in the United States of America. Security concern. First, the dynamic security protocols must be established. Access to physical and non-physical aspects of the system must be limited and monitored by the project manager. The goal is to secure information from being leaked to competitors. So one of the protocols that we can have is a non-complete disclosure for all business analysts. So even whenever they leave the non-compete commitment, so whenever they leave the firm, they should not work for a competitor. That way, they cannot leak our information or data or strategies to those competitors. Project defection. I learned the application and practicality of different system design methodologies, and also I independently explored different analytical tools and models, and design tools and models like Tableau and others, Lucid charts and all that. Lastly, these are my references, and thank you for listening.